Guys, this is the buoyant force. So Archimedes' principle. You have a boat that you built. It's about 3 feet by 8 feet by 1.5 foot, if you can picture that. And then we'll use the metric system, but and it's cardboard. You just making a cardboard boat, and it weighs around 220 newtons. So how much additional weight in pounds can the boat hold and not sink? So here's let's kind of picture this. We got our water, and then we got this boat, this volume of boat, and then it gives you the dimensions. It gives you the height, the length, and the what am I missing? Oh no, length's over here. Sorry. Width. Here's the width. And then they gave us those dimensions. So height, length, weight, height, width, length should trigger something to you. It's volume. So they gave us the volume of the boat. And then if it didn't trigger something, I'm going to jump to the equation. What's holding this, and then we'll come back to volume. What's holding this boat up is, well, here, what's pushing everything down is gravity. So you got a gravitational force down just from the weight of the boat. And then you got a buoyant force up from the water. And so then the question wanted to know, how much more weight can you add so that it doesn't sink? So equation-wise, we're going to sum up the, well, here, so what do we want? We want the forces, this goes a little back to forces. We want the forces to sum up to 0. We don't want it to sink. So we're going to have the buoyant force up plus the weight of, so this is the gravitational force of the boat, and then plus the gravitational force that we can add. So I'm just going to use a plus sign. That has to equal 0. So when we go to solve these, any floating question where it wants to know, where it's gives you something about a weight or a force, then we need this equation. You're just going to sum up the forces to 0. Buoyant force, though, is rho, the density of the fluid, times the volume displaced, times gravity, and then that's why we need the volume. So we're going to jump up here. I'm going to come back up here. We can do a quick, so that's we're back up here. So volume's going to equal length times width times height. And so you would get, it doesn't really matter how these numbers, well, here, we'll try to keep them. So it's about 2.4 times the width, which we'll just say here, that's 0.9 times the height, which is 0.5. The order doesn't really matter. Let me pause and we'll count. So we get 1.08. I would try to hold off on rounding. That's cubic meters. We're going to do everything metric, like I said. So we can come, let me keep rewriting this equation. So rho VG, the weight of the boat is mass times gravity. If they'd given us mass, then we have to do mass times gravity. But they told us the weight of the boat, so we can leave this as FG. And then the equation wants to know the weight that we can add, so we can leave that as FG. If we wanted to know the mass we can wanted, then we'd change FG to MG. All right, so now we can fill in this equation. Density of the fluid, it's the density of the fluid, not the density of the boat. So it's water. If it doesn't specify, it's water, and water is 1,000. And it's that's in kilograms per cubic meter, so we're good with, we don't have to convert that. The volume we found was 1.08 cubic meters. And then gravity is 9.8, not negative, just positive. I don't know why I said that so loud. Gravitational, yeah, what's the weight of the boat? They gave us to it. They gave that to us. It's 220 plus FG plus equals 0. And now I can solve this and get how much, oh, sorry guys, I just noticed I made a slight error. These aren't all up. I did plus signs everywhere. That's my fault for not paying attention. Some of you might have been screaming at the screen like, hey, shouldn't that be negative? The answer is yes. The buoyant force was up. That's positive. Gravitational force of the boat is down. Gravitational force of the extra force that we can add is also down. So this should have been a positive, minus, minus, and then this out here is positive, minus, minus. So what happens is when we go to solve this, it'll come out in the right sign. All right, I'm going to pause and do a calculation here. All right, so we get, so what happens is you got a negative FG, you can add that to the other side, and then you end up with 1,000 times 1.08 times 9.8 minus 220. So the gravitational, the extra force that we can add is going to be around 10,584 newtons. And then that equals, if you divide by if you multiply by 0.2, there's 0.225 pounds in a newton. Here, this says it's rounding off to 2,400 pounds. I put the answer as 2,300 pounds. So somewhere I rounded 1.08 to 1. Just be cautious with the rounding. We might be a little off, but as long as your physics is right, I'm not worried about rounding. And then the question so it can hold an extra 2,400 pounds. And then the question is, if the average person that we're putting on this boat is around 150 pounds, how many could we hold? Well, you just take 2,400 and divide this is part B. You only have to do part B if it asks for, usually it just wants to know how much extra weight or what the buoyant force is or whatever. But if I take that number and divide by 150, now I'm using the 2380, it's 15.8. So 16 people are going to sink this thing. 15 people, however, would be fine if. So it's fine if. One, you can fit 15 people on there. They'd also have to get on evenly. If you put all 15 on the back side of the boat, you're going to tip, or on one side of the boat, right? You're going to tip the silly boat. But if they could all get on evenly, you could easily hold 15 people.